This is an excellent case study in how the absence of strong synoptic forcing allows mesoscale circulations to dominate. The retreat of the ridge, the presence of surface high pressure, and the distant but influential hurricane all set the boundary conditions. But the day-to-day weather, where the storms form, how they move, who gets rain and who stays dry, is governed by the smallest actors: sea breezes, moisture pockets, and local convergence zones. At the largest scale, the southeastern United States sits beneath a weakening mid-level ridge. This ridge has been dominant for much of the summer, pressing down with subsidence, keeping skies capped and convection somewhat suppressed. But today, that ridge is retreating, opening the door for local circulations to play a larger role. At the surface, high pressure stretches down the eastern seaboard. This high provides a gentle northeasterly gradient wind into the Carolinas and Georgia, curving more easterly and southeasterly as you move down the Florida peninsula. To the east, well offshore in the Atlantic, Hurricane Erin is churning. While it's distant enough not to dominate Florida's weather directly, its broad wind field is sending long-period swells toward the coast and nudging the background wind field ever so slightly. So, the macroscale scene is one of a fading ridge, a modest coastal high, and a tropical cyclone offshore, all of which combine to create a setting where local sea breezes and mesoscale boundaries take center stage. Florida, sea breezes, and convergence. Florida today is the quintessential case study in mesoscale meteorology. With weak steering winds aloft, the sea breeze circulations hold the reins. In South Florida, light easterly flow dominates in the morning. As the day heats, both the Atlantic and Gulf sea breezes begin their inland march. With such weak synoptic winds, these breezes collide near the urban corridor from Miami northward through Fort Lauderdale and into Palm Beach County. The result is a ribbon of convergence that sparks afternoon thunderstorms. Because steering winds are weak, storms move sluggishly, meandering south or stalling, which raises the risk of localized flooding beneath slow-moving downpours. Across east-central Florida near Melbourne, the story is similar but with added influence from Erin offshore. The hurricane swell is already producing dangerous surf and strong rip currents, a reminder that hazards at the surface can be just as critical as those in the clouds. Inland, storms will blossom along the sea breeze boundaries, particularly west of the I-95 corridor and near the I-4 belt. These storms also move slowly, carrying the same potential for repeated rainfall over localized areas. In northeast Florida, including Jacksonville, the coastal ridge and drier air aloft limit thunderstorm coverage. Here, convection is more likely to pop inland, away from the immediate shoreline. The coastline instead feels Erin's reach through increased wave action and rip current risks. Let's highlight the fundamental physics at work. Subsidence from the weakening ridge. This provides a cap early in the day, suppressing convection until surface heating breaks it. Sea breeze convergence. As land heats faster than water, the inland moving breezes collide, forcing parcels upward and igniting thunderstorms. Moisture distribution. Drier air in Georgia and northeast Florida limits storm coverage, while abundant moisture in South Florida fuels stronger convection. Weak steering currents. With little mid-level flow, storms remain nearly stationary, prolonging rainfall over small areas. Remote tropical influence. Erin's wind field modifies background pressure patterns and drives coastal hazards despite being far from land. For aviation, the key hazards today include thunderstorms forming along sea breeze fronts in South and Central Florida, producing towering cumulus with rapid vertical development. Slow storm motion, leading to localized flooding and prolonged lightning threats near terminals. Variable ceilings with rapid transitions from scattered cumulus to broken cumulonimbus within short distances. Outflow boundaries, which may create sudden gusts or shifts in wind direction on final approach. Coastal hazards, with high surf and rip currents affecting marine operations and possibly impacting rescue readiness.